Okay, in the continuation of the earlier lecture, again I welcome you to all in the session School of Agriculture for the course of food processing and engineering 2 for the diploma of food value-added products for the fruits and vegetables. This course contain this course will contain the 5 blocks, and these 5 blocks actually. Block first, that is the food produced by application of the heat, and block 2, this covered the food produced by removal of waters, and block 3 is the food produced by through the temperature reduction and by controlling and by irradiation, and block 4 is contain the product utilization, and block 5th, that is food packaging. Here I am not going to cover all the blocks, so here I am concerned only the second block, that is the food produced by removal of water. Particularly this block contains the 2 units, that is the forms of heat, water and absorption or disruption of the water in the food and water activities, and second unit, that is covered the drying, dehydration and evaporation. These both the units I will discuss in the details. Then first one, for example, forms of water in the food, absorption and disruption of water in the food water activity. The water is the major constituents of the fruits and vegetables, and a high amount of sometimes water in the foods cause the perishability of the fruits and vegetables. It also alters the physical and chemical or enzymatic changes in the food products. The removal of the water from the fruits and vegetables, that is dehydration and evaporation, can be removed by these methods, and the reduction in water extends the storage life and shelf life of the vegetables and their products. Then coming to the water activity, water absorption or isothermal. Water absorption means just absorption of the water from the food, and isotherms is the actually this is the graphical relationship between the water content and the water activity. Here you can see when the product is stored at the different relative humidity, then it absorbs the water from different relative humidity. So if the water is taken by the food at different relative humidity, then it is content that is called absorption. That is called absorption of the water taken by the food. But the same way, when that getting the equilibrium of getting the high moisture in the food, then after that, if you reduce, you see on the different lower the RH of the food, then you can see the water is moisture is taken from the food. So moisture taken by the food, that is called adsorption. So what is this difference is greater at 5 degrees centigrade, are not detected at the high temperature, that is 60 degrees centigrade. So here you can see in the figure, the one side, that is right hand side, there is a formation of loop. You can see the water is taken by the food, which is absorbing at increasing the relative humidity. By the upper one, that is the deabsorption, where the food is taking the or removing the moisture at different, lowering the different relative humidities. Then water activity, this is the ratio of vapor pressure of the solution compared with the vapor of the pure water at the same temperature or equilibrium. Actually, water activity is just the relationship of the product and equilibrium or relationship of the product and divided by 100 degree. Divided by 100. Here the water activity selected by semi-solid food varies the product to product. For example, in case of semi-solid it is 0.8, while in case of dried fruits it required 0.6 activities. Water activity affect the quality during the processing, storage, transportation as well as marketing. So it play a very important role in process products and storage during the storage. Then coming to the water activity availability, what are the water activity which affect the quality of the product? If you see at less than 0.1 water activity, there is no production, no microbial or non-enzymatic browning spoilage occur, and the water activity coming between the if water activity is between the 0.6 and 0.6, then the only non-enzymatic browning occur. If water activity exceeds more than 0.3, then enzymatic or deterioration type of spoilage is occurred. Then if water activity is increases more than 0.7, then mold, yeast and activity start, but bacterial growth is not started. If water activity is increased more than 0.8, then the spoilage of bacteria is occurred by the spoilage of product is occurred due to by microorganisms. Then coming to the effect of water activity on the enzymatic reactions, here you can see enzymatic reactions are generally suppressed the reactions at low water activities. So water activity of the food increased by enzymatic reactions rate as increased. There are some stabilizing substances which can be added into the preparation of the enzyme solutions, that is called sodium chloride or glycerol or polypropylene. These can be added just to suppress the stabilizing or activity of the enzymatic enzymes. Doing this, for example, if you increase the enzyme activity can be reduced by the addition of the 2 to 3% solution by addition of, in case of proteolytic enzymes, that can be inhibited up to in the range of 0.6 to 2.8% water activities. In the same way, the lipoxidase and the peroxidase enzymes can be inhibited by the reduction in their optimal activity at the 0.4, 0.94 and 0.97, so by addition of the 0.2 to 3% of glycerol. So that can be added into the different into the enzyme solution when the preparation of the enzyme solution, so just to reduction the water activity or stabilizing. Then coming to the non-enzymatic browning. Non-enzymatic browning, the effect of water activity or non-enzymatic browning. Actually, this occurs in case of processed products. Low water activity reduces the browning due to the low mobility of the reactions. So the temperature, some of the factors like temperature, pH, and water activity affect the non-enzymatic browning reactions. The maximum rate generally in case of fruits and vegetable products is occur at the 65 to 70% relative humidity. Water activity need to reduce from 0.65 to 0.75 to 0.4 to 0.50 for the intermediate foods. So intermediate foods are those foods which has been processed or content have the high amount of moisture, that is 20 to 20%, but they are stable at room temperature. There is no need to store into the refrigerated foods. In case of dehydrated foods, the activity need to reduce the 0.65 to 0.75% 75 water activities. Then effect of on microbial growth, actually the food is spoiled by microorganisms. If the in case of water activity more than 0.9, then bacteria are responsible for the spoilage. And a water activity 0.9 to 0.6, the yeast and mold sometimes spoil the products. And of water activity is 0.6 more than 0.6, then most microorganisms are generally inhibited. Then coming to lower water activity, pH, salt, and these be added into the product, then they act as an energetic effect. Then effect coming the next, then effect of water activity on the storage conditions. So they quickly moisture migration cause the condensation. Condensation of the moisture on the surface of the can container spoil the labels on the top of the container, or sometimes cold or rust is there due to the which can favor sometimes mold attacks. At the 70% RH relative humidity or 30% degree centigrade temperature, air becomes saturated. If you reduce the temperature below the 30 degrees centigrade, just only 6 degrees centigrade, then it will permit the mold growth. So there is a need to maintain these levels always just to reduce the water activities. Then coming to the effect of water activity on the packaging materials, there are basic flexible materials are the basic materials are the plastics, aluminiums, or regenerated cellulose or papers. Sometimes thick films actually have the low permeability, greater strength, higher cost, and production with low water activity. Products which have the low water activity, for example, in the case of dehydrated foods, which are generally hygroscopic in nature, they have to pack at the lower water activity and in the package which are impermeable in nature. Then coming to the what are the factors which are affect the water activities? There are some factors like water absorption. Water absorption property of the substance means actually which type of food is there, whether it is liquid or semi-solid or whether it is dry. So how it have the capacity to absorb the moisture from the atmospheric conditions. This also affect the water activities. Then acidity and pH of the media, how the acidity, how much acidity or whether the lower or high side, and the same way the pH, whether the lower side or acidic side or alkaline side, so how it is available, that it also affect the water activities. Then moisture content is also affected by the higher moisture content, low water activity, and then low moisture, then higher low water activities. Then temperature fluctuations. Sometimes product is stored at the different temperatures. So there is, due to the electricity, there is fluctuation in the temperature during the storage. So if temperature is stored, the fluctuation of the temperature is more, then water activity sometimes may be some subject decrease or increase. That depends on the nutritive value also affect the products. The nutrient value also affect the water activities. Then presence of nature and solutes. In the solids, so this is also affect whether it is solid form or semi-solid form. So these are the some factors which are affect the water activity in the product. Then coming to the measurement of the water activity, what are the devices which are available for the measurement of the water activity? There are certain devices are available, like for example, electric hygrometers, use of saturated salt solutions, use of psychrometric methods, that is water activity apparatus, and hair hygrometers, and dew point instrument. Out of 5, only electric hygrometer and use of saturated salt and dew points are the commons which are generally used to measure the water activities as a commercially, and others are also have, but not in the as a commonly used. And coming to the evaporation, this is nothing but it is a process which is heating process, which is in which water is removed from the liquid substances. The significant advantage of the water evaporation are that just it reduces the weight and volume. Reduce the weight and volume, and then storage space, and the packaging, transportation cost, and also it reduce. Then it prevents the microbial spoilage, and little thermal degradation also occurs. So by evaporation, because of it reduces the maximum moisture from the juices. So if the juice contains the maximum percentage, that is more than 100% of the moisture, that at which microorganism easily attack on the attack the product. But by evaporation, moisture is reduced to a certain level, or will become the concentrated to 6 to 7 times of colder. So by concentration, moisture moisture is very less at which moisture level microorganisms cannot attack. So this is one of the advantages of by the evaporation methods. Then what are the methods which are available for the evaporation? There are so many methods which are available for the evaporation of the juice or other type of materials. Like solar evaporation. Solar evaporation generally used with the help of solar energy, generally used into the sea level for preparation of the salt from the sea waters. Open kettles, this is also used for open kettles by the help of evaporation. And flash evaporation, this is for this type of evaporation, generally flash evaporation or called juice concentrations, concentrated by which you can evaporate the materials. Then thin film evaporators, then vacuum evaporator, which also have evaporated where with the help of vacuum pump. Freeze concentration, where the first product has to be freeze, then after that by simultaneous application of the vacuum, the can be concentrated. Then ultrafiltration, reverse osmosis. In reverse osmosis, there is some here the product becomes a liquid, and product with solid side and solid side. So this is called reverse osmosis. Then plate evaporator, these are sometimes of heat exchanges are evaporator is there. By this that can be also evaporator. Then membrane, concentration, and then centrifugal evaporator. So many different types of evaporators are available that can be used for the evaporations. Then coming to types of evaporators, actually there are 4 or 5 types of evaporators are available. For example, best type of pan evaporators, forced circulator evaporation, rising film evaporator, falling film evaporators, rising film evaporator, and agitated thin type of evaporator. I will discuss one by one. For example, this is the best type of evaporator. The best type of evaporator, you can see in the figure. This is a figure of the best type of evaporators. Here this is the simple and old type of model. Here the vacuum permits the boiling at a temperature lower than the boiling point. It reduces the thermal damage to the heat sensitive product. For example, orange juice. If you concentrate or evaporate, then it will be a better quality of the juice. Then heat transfer area per unit volume is less because it has the certain disadvantage, because heat transfer area is very less as compared to the other evaporators. Residency time is very long. Here it took several hours as compared to the minutes. So heating, here the heating is occurred due to the natural convection. Why? Because this is the liquid, so the liquid here steam is passed to the liquid, so that it becomes started the concentrated, then by concentration by boiling, then vapor is produced, the vapor go upward, then from there they can go outside, and product after concentration it becomes a lower side. You can see in the figures the product is received. Then this is the second coming to post circulation operators. Post circulation operator, these are operated as force circulation units. These operators are capable for concentrating the viscous type of liquid materials. Here the adequate circulation takes measure circulation rate measured by the use of suitable pump. Here the centrifugal pump is used for the low viscosity liquids. In the figures you can see, this is the figures of the forced circulation evaporator. There the steam is passed to the product, and product is in the lower side the pump which is forcing the product to the upstairs, then boil it. With the help of steam, product is boiled, then they become the concentrated, and then the vapor go upwards and then go outside, and the product is concentrated product is received from the lower side. Then rising film evaporator. Rising film is also one type of evaporators. This is also useful for the low viscous liquids. Here the liquid rises inside the tube by vapors near the bottom of the heating tubes. Here the difference is at 14 degrees centigrade between the product and heating medium obtained well-developed film. And the operation here, the operation is go once through. But if it is necessary, then the product can be recirculated or recirculated again. So here you can see this is the bottom side, the product is feeded, and then the steam is passed from the upper side. Then after concentrated product will falling down at the bottom, and then some water vapors go outside, and as soon as product is concentrated, then is taken out from the evaporators. Then falling film evaporator, this is the same, almost same. Here the this type of evaporators are used for the more viscous liquids than the rising film type evaporators. These type of evaporators are suited for the highly heated sensitive products such as orange juice. Here the residence time is 20 to 30% centigrade per seconds as compared to the 3 to 4 hours in case of rising films. So this is the one advantage of falling films in compared to the rising films. Then rising and falling film evaporators, this type of evaporator is used to product here you to consider the product by circulation through a rising film section followed by falling film sections. In this type of evaporator, the product is first concentrated in the rising film section, then followed by the falling section. Here the finally attain the final concentrate. That's why it is here the product is concentrated in two sections: falling section and rising falling section and rising section. That's why the name has been given the rising and falling sections, falling film evaporators. Then again agitated type of evaporator. You can see in the figure this is figure of the agitated type of thin film. So here to provide the higher heat rate transfers and higher pressure steam used for the heating medium to obtain the high well temperatures. The major advantage by this arbitrage here high capital and maintenance the cost, high capital disadvantages are high capital and maintenance cost and low pre-cooling capacity. Next is coming to the drying actually. And drying, as you see, the drying means just removal of the water. That's removal of the water from the food before sent to the water generally referred. But here you can see there are two terms, drying and dehydration. Drying and dehydration, if you see the purpose of both drying and dehydration is the same. But if you see on the particularly, then they are little bit indifferent. For example, in case of drying is a process in which moisture or water is removed by non-conventional sources like wind and sun. While in case of dehydration is a process where the artificial heat is given or provided to the product just to dry the waters or dry the moisture from the product under the controlled condition like temperature, relative humidity and air flows. So this is the difference between the drying and dehydration both. You can see purpose are simple. What are the objective of drying? Drying and dehydration it have two objectives. So one is to reduce the weight and bulk. Basically, main purpose of just to reduce the weight and bulk. If you see in the case of drying, actually fresh fruits and vegetables contain a very high amount of water. That's why we call the highly perishables. But by drying, you can reduce the water at least 1/6 or 1/6 to 1/9 of the product. So by reducing this much amount, the product is reduces the 1/6 or 1/9 less space as compared to the fresh one. So if you reduce the space or reduce the quantity or reduce the bulk or weight, it will also reduce the cost of transportation, packaging and storage space, etc. So this is one of the objectives just to drying or dehydration. Then second is one is to reduce the water activity. Actually by reducing the water activity, the water moisture content is reduced. So definitely moisture content reduces, the water activity is reduced. And because by drying and dehydration, water activity is this much generally reduced up to the 0.6 at which microorganisms cannot attack. That's why in case of fresh fruits, vegetables, due to the high water activity or high moisture content, the microorganism fungal dosage. So by drying and dehydration, microorganism water activity is reduced. Then coming to the principles, principally in case of drying, there are two principles in case of drying dehydration. Just to remove the water from the fruits and vegetables. But here, in case of drying, air had two main functions. One is just here air has two functions. Just one get the heat into the product from the just a minute. Here air has the two functions. Just we get the heat into the product and by the heating devices, and the second other objective is just to get out the mass from the heat from the post product. Then what are the mechanism of dehydration? Here you can see that in case of mechanism of dehydration, there are 4 steps are generally occur. One is heat and mass transfer phenomena and development of dried thick layers and establishment of moisture gradient and normalization. In case of heat mass transfer, this is the one type of phenomena. We must get the heat into the products and we must get out the moisture from the products. But both these two occurrences are not occurred in the same times, simultaneous conditions, because if you, for example, if you apply the heat into the some same type of container or the same conditions, then there is a heat will be produced, but there is no space for the accept the moisture. So to provide the dry the properly conditioned and or the product, you have to escape the some moisture or ventilation to just escape the waters. Then that one development of dried moistures. So for example, at the initial stage of water is removed or the surface of the products. So apply the temperature or force the temperature. So the temperature is forced to product to dry or evaporate the water from the surface. So after some time, so you see the upper layer of the product or surface is dried, that is developed, that is called dried thick layer. Then after that, sometimes if you can drying process you continue, then you can see the development of dried moisture gradient. Moisture gradient means that once the dried thick layer is developed, then from the heat from the outside, which is given by the heating devices, that is not hindering in between, going to the inside. In the same way, the water which is available in the center of the product, that has to travel from the center to the outside. So if it will hindering the development of dried thick layer, it will hindering both the conditions. So because traveling distance is in between from the center to the product surface is less or higher, so it will take more time, so it will hinder. The next is that the normal ER. Normal means is nothing, the RH. When the drying process continues, the product dry to a certain level of moisture. After that, it will not be dried. Either you dry for the longer duration or small duration. So if you wish to dry the product reduce the more leakage, then you have to change the drying condition. For example, if you dry to the, dry that low temperature, then you have to you have to change that relative humidity or drying condition. Then coming to the why dried the foods. Okay, because you dried foods, rehydrated foods hardly affect the calories or micro because they are concentrated. Now that's the one. Then unlimited shelf life or proper. If the dehydrated product is stored, that the shelf life, the proper store, they have the unlimited shelf life. Unlimited that they can be stored for the longer, 1 year or 2 years. Then transportation, handling, and storage costs are significantly reduced. So that I have discussed in the earlier, by drying it reduce the weight and bulk, so that if you transport to the longer distance or you store for the in the proper storage conditions, it requires less packaging, less storage, less handling and cost. Then you provide the uniform modern marketing requirement. Means some different locality require different type of product. For example, some people want the powder form, sometimes keep form, sometimes of the slices form. So on that requirement, the product can be converted to the different forms of the product. If locality required a powder, then powder can be converted. If locality required to the slice paper, then product can be converted to slices. So that is called modern requirement. So by drying and dehydration, you can convert the product into different forms. Then consumers uses all that. By for example, it's whatever in case of whatever amount of dehydrated product you buy from the market, you can consume whole thing. For example, in case of if you buy the fresh fruits and vegetables from the market, then from that hardly you will get only 60 or 50 or 60%. The rest of the wastage will be there. But by dehydrated product or ready to use products which you buy from the market, that you 100% you can use. So that's why dehydrated fruits and vegetables generally preferred. Then coming to the types of drying, what are the types of? There are 3 types of main drying. Then sun drying. Sun drying is generally occurs in the plenty sunshine is available, or there is little or no rain is available. Here some fruits, small fruit like fig and grapes, they can dry in the sun with the help of sun energy. Then other one is called atmospheric energy. This is the artificial. Here the mechanical, or you can say mechanical dehydration, where the artificial heat and the controlled condition like temperature relatively that it provides. And vacuum dehydration, this is provided generally done in case with the help of vacuum. And with the help of vacuum, here the heat input and temperature is controlled by regulating the heat inputs and heat intensity and regulating the vacuum intensity. Then coming to that, what are the factors affecting the drying rate? These are the temperature. Temperature is generally, as you know, temperature plays very important role. So they force to that product to play force to the evaporate. So if temperature is higher, then the rate of drying will be faster. If temperature lower, then the rate of drying will be slower. Then in the same way, the second is air velocity. Air velocity is also play very important. Higher air velocity, then means rate of drying will be faster. If it's slower velocity, rate of will be slower. Then size of the product. Size of the product is one of the best factor which affect the drying. For example, that's why you might have seen during the drying, the product is divided into the sub-products. So because by cutting and peeling, it is divided into some pieces because it is dried faster. If product size is larger, then rate of drying will be slower. If product size is smaller, then product of the dry will be slower, smaller than product very fast and large size. Than, for example, if you see there are two main regions. If product size is bigger than heating, which has to go from the heating device to the center, and the other one is that moisture content which is available in the center, that has to travel from the center to the upper surface of the product and then to the atmosphere. So the travel distance means in case of larger size of product is very large, while in case of a small size of product, the distance, travel distance is very going to travel distance reduce to lower size. So this affect the rate of drying. Then surface area. The surface area is also affect that rate of drying. For example, if surface area is bigger, then drying rate will be faster, or product will be dried faster. If surface area is smaller, then drying rate will be slower because the region is same. If the surface area is bigger, then evaporation will be faster. Or on the other way, the contact of the heating will be bigger as compared to the smaller area. Then RH of the air. RH is also affected by the type of stage of the RH and method of drying. For example, at any in the stage of drying, when the product is loaded into the drying, that time a higher relative humidity is there. So the slower rate of drying is there. Then after sometimes product is dried, then RH becomes lower. Then RH becomes lower, then rate of drying will be faster. It's a high velocity compared to the drying air, then rate of drying will be faster. But as you see in the dehydrated products are very hygroscopic, they have the capacity to absorb the moisture from the outside due to the hygroscopic nature. So if you wish to dry the certain level of moisture, then then drying condition has to be changed. For example, if you see that this is the isothermal product, here you can see if you dry the product at 100 degrees centigrade, you see at 40% relativity, at 100 degrees centigrade contain the moisture content and 4% moisture. But if you wish to dry the product at below the 4% moisture level, then you have to change the drying condition or relativity, that is less than the 40%. So you have to reduce the relative humidity instead of 14 to 20 to obtain the 0.2% relative moisture content. Next is coming the water, the processing for dehydration. These are some different steps which are available, like washing, flexing, peeling, preparation, slicing, sulfiting, and drying, and treatment and dehydration, sweeting, packaging, then storing. These are so many steps which are generally used for processing or dehydration. Then coming to the pre-treatment, what are the pre-treatments? The washing coming to the pre-treatment washing generally done in case of fruits has to be washed by the cold water. Then after that peeling, they have to peel by the hand or by the machines. Then after that they have to convert into the slices or some other cubes force or the shreds force, whatever requirement is there. Then after that they have to prick just to make the porosity. Then you have to soak into different solutions. Then electron dip generally done to small fruits which have to dry as a whole. For example, in case of grapes, blanching is just done just to inactivate the enzymes. In case generally done in case of vegetables, just to indicate. Then sulfuring is done just in case sulfuring, the fruits are exposed in the sulfuring just to inactivate the fumigation, the sulfur fumes of the fruits. Then after that sulfiting is generally done by dipping the fruits vegetables into the sulfide or KMS solution. Then after that blanching. Now coming on blanching actually is nothing but blanching is a partially pre-cooking treatment which is generally done in case of fruit vegetables, because vegetables have some certain enzymes, for example peroxidase enzymes which has to be destroyed before processing. So that is done by blanching. The purpose of blanching is just to reduce the drying times and remove the intercellular forms of the tissues, and then contain the some carotene, ascorbic acid, and then remove the some pungent. Sometimes people don't want the in case of pungency flavors, in case of onions, so that can be reduced, and then improve the dried transportation appearance, succulent of structure. That may be can be done by the then coming to the sulfuring in which the whole fruits and vegetables actually are exposed to the fumes by burning of sulfurs inside closed chambers for the 30 to 60 minutes. Then purpose sulfuring, there is a pre-treatment to oxidation of blanching. Then sulfur act as an oxidant or degradator. It is done to check the growth of molds and prevent the cut fruits from the fermentation. Then prevent the vitamins losses. Then you can see this the sulfur box here. Fruits and fruits after giving the pre-treatment, they are fumigated with the sulfur by burning the sulfur. You can see that in the pot, the sulfur powder is burned at the rate of 4 to 10 grams per kg of fruits. Sulfur powder is burned just to get the product. After giving the sulfur 4 to 6 hours, then product is taken out and dried into the dehydrators. Different types of dehydration. Then coming to the sulfitation is this process. This is dissolving in the chemist is turning in the sulfur by SO2 by giving the chemist into the water. The purpose of sulfiting is just to maintain and protect the colors, prevent the spoilage, and it preserves the certain nutritive attributes until the marketing, and act also antioxidant to protect the carotenoid and ascorbic not contain the dried foods. Then drying ratio. Drying this is the recipe of fresh materials. Here the knowing the water content of a fresh material entering the dryer and of the product leaving the dryer. The drying ratio or reciprocal drying ratio can be calculated by weight of fresh material entering into the dryer and the weight of material by leaving the dryers. Then coming to the what are the factors which affect the drying ratio? There are so many factors which affect the drying ratio. Right, variety is also affect the drying. It's variety, different types of varieties, whether it contains the high amount of water or low amount of butter or good quality of nutrient or pulp, etc. So then the growing conditions is also affected, whether in which type of condition is growing, and time of harvest, whether it is harvested at morning or evening, that is also, or harvested 2 to 3 days before. So this is also affect the drying ratio. Then grade of raw material, whether small size or large size or medium size, this is one of the types of also affect. And loss of preparation, how much losses are going on in the preparation. Then drying ratio should expressed in the weight, because the dry matter remain the same or only water content change. Then because to the quality of the raw material absorbed by dehydrated means the replacement of quality water replacement of the dehydrated foods, or dehydrated is weight of dehydrated samples and weight of dehydrated samples that can be calculated by formula. This formula. Then this is the coefficient. For example, if the dry weight of 10 gram of dried cabbage contain the 5% moisture, and after dehydration 90 gram of fresh cabbage before drying contain 96%. This you can see by calculation. This can be calculated by just the coming 0.07. Then coming what are the conditions which are required for better dehydration. Right, time of soaking and boiling of for preparation of quality of the product, and least amount of water, and that submerge the pieces of the production of water. Then shaking and stirring necessary to enter the water, because they control the rate of heat rating variations, and varieties and variable losses of water which while boiling. Then this is the constant falling rate. You can see the initial moisture content, decrease from the A to B, that is in temperature increases, and that sometimes there is reduction in the B or C, that is the constant rate, that is called constant rate. And after that continue of the drying, the moisture content decreases, that is called C, D and CE, that is called falling rate. So this is that you can see in the figure, this is the falling rate and constant rate that has been shown. And then coming to normal drying rate. Normal drying rate can be being the drying, water continue to evaporate from the fruits. So water continue to evaporate up to the, you can see the continued drying up to the constant rate, that is called up to the 1 to 4 temperature, 1 to 4 hours, and then after that you started the falling rate into drying. So up to the drying. So that is normal drying curve. You can see the time. Then after that, what are the after drying, what are the condition becomes typical. For example, this you can see this. The first one is the original piece of the drying, that vegetable dyes. You can see. Then after sometimes moisture drying is started, then it become the shrinkage. In case of B, you can see. Then finally it becomes the concave shapes and cave shape tape due to after shrinkage toward the center of the product. So this is the after drying and before drying. You can see. Then what are the methods of drying? There are so many types of method drying. There's sun drying, that is done in case of sun drying. Then mechanical drying, there's artificial drying. Here the artificial method. Pre drying, that is done by freezing. There's osmotic drying. The osmotic drying, osmotic drying is done by the just osmotic, in which fruits vegetables are dehydrated osmotically by immerging the fruits and vegetables into the sugar solution. Then microwave drying is the latest one. Here the electric magnets are applied. Then foam-made drying, there's some juices here. There's some foaming agents like egg, aluminum, and granite proteins are added just to do that. Then vacuum drying with the help of vacuum drying. Then pre-drying treatment. These are the some treatment like sweeting. Sweeting is nothing but this is the actually in which a product is held for the sometimes, that is equalize moisture, the packaging for 2-3 days. Then after that packaging, different type of packaging. In package desiccant some desiccant type of material like silica calcium oxide or silica gel oxide just to absorb the moisture which is remaining in the product. Then retentive measures of the spray. These are some recommended quality of the spray as well as retention, optimum drying temperature, storage food at low temperature within the use of package free from microbials, hygienic condition, disposal products. These are the some preventive measures which are given. Then this is the schedule for giving the drying fruits. Then these are drying towards the vegetables. Then here you can see. Then this is the for the continuous different types of vegetables. This makes your vegetable branching time. These are the some drying, different types of drying dehydration. There are two types of solar drying dehydration, solar drying type equipments and butter dehydration equipments. Here you can see one by one. First one is solar drying equipments. Solar drying equipments, so this is the direct solar dryer. Here this is made of glass or plastic. Here hot water or hot water solar energy used just to dry the food. Then this is the 10 type of solar dryer. This is made of 10 types. This is also made from the 10 types. Then this is the back throw dryers. Here this is also made from the plastic film made of plastic frame or wooden frames. Here you can see back in between. That's why it's called back. So you can put a load of the product. Then this is the 10 type of chimney type of dryer. Then you can see. Then after that you can this indirect chimney dryers. This is also made by glass and wooden boxes. Here the product is you get the energy from the sun. Then water moisture evaporated. Then it go to the in the chimney from the outside. Then coming to dehydration, this is the cabinet dry. Heat cabinet dry, the fresh air is coming from the outside. Then the product is heated by the blowing of some hot air by the heating devices. So hot air goes into the product, and the product get the heat, then start the evaporator, and then it goes outside. So this is the then tunnel dry is also one type of dry, 20 to 32 centimeter long tunnel is there. Then the product is enter from the one side to the other side. So as soon as product goes from the one end to the other side, it dries. So then this type of space type is generally used for the sophisticated type of just orange juice or tomato juice. This product is introduced in the form of a spray by after getting the high speed of heat. Then product becomes droplets, then powder form that the whatever moisture that comes, it comes outside. Then this is the drum type. The drum here the product have the some semi-solid type of paste like paste or puri that is loaded on the steam heated drum on the surface. Then a product heated round side loaded, then rotated. It comes from the one side to the other side. That is blade. We just cut the product into the by the this is the vacuum side. The product is headed or loaded into the belt which goes to the other side of the heating drum. Then product heated, then it goes to the other side. That is the cold drum where the product is cold. Then after that is continued to the this the product where dries. The product is let into the bedded, and then heat is provided from the bottom sides. Then coming the product, then these are some drop osmotic dehydration, pomade drying, then intermediate moisture drying, then micro drying is the micro down, then slush down is that to overcome the slush drying, just mechanical drying, you heat energy wastage to damage the product, that to overcome the slush energy. And modified drums, sometimes reverse osmosis is the product also reduces from the solutes by the simple membranes. Here product becomes the, you can see this is the drum dry product, because the dehydrated product becomes the hygroscopic in nature, so we absorb the moisture from the outside. To overcome this problem, that we have developed some maintain the relative humidity by 30 to 40 degrees. Where the product becomes cut by cutting. Then this is the reverse osmosis. Here the hydraulic passage product generally becomes slow from the high concentration sometimes, but in case of reverse osmosis the product is so here due to the higher the pressure, osmotic pressure or hydraulic pressure, or lower the osmotic pressure, the become the product become liquid and as compared to the osmotic. This is the presentation. This is the summary. The product and vegetables nature contain the water content frequently, and the butter act as a soluble in the food product, and the insulin and the microbial enzymes and non-enzymatic conditions, and controlling the water content of the concentration food solution in the food may be stabilized. And removal of water from the food is primarily food done lower in the water activity, so that it also saves the energy, moisture, and space, and shipping, packaging, storage, transportation, and vegetable which are known as high value acidic or low acidic fuels. And thank you very much. Thank you.